I can use the tangent ratio to solve for the missing side of a right triangle. Always write SOHCAHTOA at the start, at the top of every page. We're dealing with tangent, we're dealing with the opposite and the adjacent. So take a look at these three triangles below. I want us to realize something. Do we notice how they're all right triangles? So they all have a 90-degree angle. Do we also notice they all have a 40-degree angle? They share two angles congruent. So these aren't congruent triangles, but they are similar triangles by angle, angle. Because they're similar triangles by angle, angle, that means their sides have to be what? Proportional. Which basically means if we reduce a comparison of sides, they're always going to reduce to the same thing. Let's take a look. Tangent of 40 degrees. So this is my reference angle. I'm going to do this 3 times. Okay, here's my reference angle. My hypotenuse is always the same, although I'm not using it right now. My opposite. And my adjacent. So here's the thing. Let's do the tangent of 40. It's opposite over adjacent. What is the opposite from 40? It's 2. What's the adjacent to 40? 8. Okay, what is the opposite of this 40? 5. The adjacent? 20. Just doing tangent. Tangent of 40, the opposite is 7. The adjacent, 28. Now those all look very different. But if we reduce them, we get 1/4, we get 1/4, we get 1/4. And so it turns out that all of the sides, the tangent of 40 in each of these 3 triangles reduces down to the same thing. So the tangent of 40 degrees in all the triangles reduce down to 1/4. Now 1/4, couldn't we also say 25 over 100, 25 hundredths? Or couldn't we even say 25 hundredths? I want to put that out there because we'll see things written in different formats today. So they all reduce down to the same thing. And basically what we're saying, and this is the most important part, what we're saying when we see tangent 40 degrees, and in this case what we can do is we can say it's equal to 25 hundredths, which is really just 1/4. Tangent of 40 degrees is always going to be 25 hundredths, or 1/4. It's always going to be that way, and this is why. We mean all right triangles with a 40-degree angle. And I know I'm dealing with a right triangle because sine, cosine, and tangent only work in right triangles. So as soon as you see tangent, cosine or sine, you know you have a 90, and then in the other angle that follows, you know you have 2 angles in common. Okay, so they have to be similar triangles. So all right triangles with a 40-degree angle, okay, will always be similar by angle, angle similarity. Therefore, the ratios of the side opposite 40 to the side adjacent 40 will be proportional. which really means reduce down to the same thing. So let me zoom in a little bit on this. Okay, think about it. You have angle-angle similarity, so the sides have to be proportional. And we always have angle-angle similarity whenever we're doing trigonometry because they're always right triangles. Sine, cosine, or tangent means we have a 90, plus one more they have in common. Every single right triangle, the side opposite the 40 compared to the adjacent to the 40, it's always going to reduce down to the same thing. So we can use this idea to solve some different problems. Let's take a look down here at example 1. Okay, we can go with similar triangles for our first method. This right here means if I were to sketch another picture, okay, and put an 18 degrees in the same spot, it can be a bigger triangle, smaller one than this one, doesn't matter. The tangent of 18, meaning the side opposite 18 over the side adjacent to 18 in a right triangle, will every single time reduce down to 32 hundredths. That is 32 hundredths. So I can go ahead and say, well, this must be 32, this must be 100. And that's absolutely right. Every single right triangle, the side opposite the 18 over the adjacent, has to be 32 over 100. Here's a right triangle within 18 degrees. This side needs to be 32 over 100, but it's not. It's 4 over something. So you can set up a proportion and just say that these guys are equal. You can say 4 over x is going to be the same thing as 32 over 100. They have to reduce down to the same thing if they're going to be proportional. And they are because they're similar by angle-angle. So now you can go ahead and cross multiply, or you might consider reducing first. It's up to you. If you reduce first by 4, I think you get 8 over 25. Might be a little easier to deal with. You get 8x equals 100. Divide both sides by 8. And what do we get? I'm going to have to go do a little bit of long division, I think. 100 divided by 8 goes in once. 8 goes in twice. A space, put the decimal point. 5, there we go. So x is going to be 12.5. And we should always round to the nearest tenth, let's say, right here. It terminates the tenths, so we're okay. But if it kept going, maybe just go out to the hundredths and then round to the tenths. And so 12.5 is the answer here. So 4 over 12.5 and 32 over 100 always reduce down to the same thing. Now, this is a method by setting up a similar triangle. I'm going to show you a different method over here called substitution. Another way to do this is to take this phrase right here and just write it again. Except I'm going to write it with 32 hundredths as a fraction. And what is the tangent of 18 degrees? Well, in this case, tangent of 18, here's my opposite, here's my adjacent, because that's what tangent is. Every single right triangle, the side opposite over the adjacent, has to be 32 over 100. Opposite and adjacent to 18 degrees, that is. So I'm going to put whatever the tangent of 18 is from here, right here. It's 4 over x. So I'm going to substitute it straight in for this, 4 over x. And then I do the exact same process that I did to the left. So you have your choice. You can go ahead and set up a similar triangle, and you can see the proportion right here and do it. Or you can just say, let's change this to a fraction, and what is tangent of 18? Substitute it straight in and go. Here's your problem here for a check-in. Go ahead and try it out. Okay, here I go. Tangent of 22 degrees. Hit pause if you still want to try it. Here's my opposite. Here's my adjacent. I'm going to rewrite this. I'm going to say the tangent, 22 degrees. is equal to 4/10. Be really careful. That's 4 over 10, not 4/100. And then I'm just going to substitute. I'm going to substitute straight in for this. What is tangent of 22? Well, SOHCAHTOA. TOA is opposite over adjacent, so it's x over 15 right here. And so I can go ahead and cross multiply. You might consider reducing first, but I'm not going to because I love having a 10. 15 times 4 is 60. I love having a 10 here because then when I divide by a 10 or 100 or 1,000, every time I have a 0, I'm going to move the decimal point one spot. So this is 6. I like it. So I'm not going to reduce in that case because I want to preserve that 10. So there we have it. Choose either method, similar triangles or substitution. Both work just fine. Good luck.